Hello and welcome to this video on topic of ExCAT questions based on geometry. Now, geometry as a topic has been scaring a lot of students, and most of the students feel that geometry is a difficult topic. In this video, we are trying to demystify that myth. Let's begin with the first question that actually came in CAT based on geometry. The question is, in the adjoining figure, chord ED is parallel to diameter AC of the circle. If angle CBE is 65, then what is the value of angle DEC? Now that's the question. You can see in the figure. To solve this question, let's do a small construction. Let's join AE. Now joining A and E, what do we get is that arc EC subtends equal angles at points A and B. And because angle EBC is 65, therefore EAC also has to be 65. We also know that angle AEC is 90 degree because the angle in the semicircle is always a right angle. Now in this triangle AEC, we already have angle A, angle E is 90 degree, and therefore the third angle, which can be easily found out because the sum of all three angles is 180. So angle ACE is equal to 25 degrees. But we also know that AC is parallel to ED, and therefore alternate interior angles, angle ACE and angle CED will be same, and therefore the question which is asking angle DEC will be equals to 25 degrees, which is option 4. So what we saw was a pure circle question wherein a simple property of circle that angles subtended by one arc at two distinct points on the circle are equal was being used. So if a simple property of a circle is being remembered, a question like this, which was a 2-marker question of CAT 2004, can be easily cracked. Let's move on to second question. So question 2 is, if the lengths of the diagonals DF, AG and CE of the cube shown in the adjoining figure are equal to the three sides of the triangle, then the radius of the circle circumscribing that triangle will be how much? And the options are given to you on the screen. Now, if you understand the question, DF, AG and CE are the diagonals of the cube. We know that in cubes, all the diagonals are equal. That simply means that if DF, AG and CE are the sides of the triangle, then the triangle will be an equilateral triangle. We also know that in equilateral triangle, the height is equals to root 3 by 2 times of side. But this side, which the triangle is being formed, is the diagonal of the cube. And if I assume that, let's say the cubes is of side A, then the diagonal will be A root 3. And this A root 3 will become the side of the equilateral triangle. Therefore, height of the equilateral triangle will be root 3 over 2 times of A root 3. What do we need to find? We need to find the radius of this circle. We need to remember this simple understanding that radius of the circumcircle is always 2 by 3 times the height of the equilateral triangle. How did it come? By understanding that in an equilateral triangle, the perpendicular, the median, the angle bisector are all the same lines, and therefore the centroid will be also the center of the circumcircle that will be drawn on the equilateral triangle. And therefore, we know that centroid divides the median in the ratio of 2:1, and thus circumradius is 2/3 of the height. On simple solving, we get 2 by 3 times the height, which is root 3 by 2 times of A root 3, and I just get the same A back again. What was A? A was the side of the cube, and therefore my answer is option 1. This, my friends, was a question of CAT 2004. In CAT 2004, there were two types of questions. There were 1 markers and there were 2 markers. This was a 2-marker question. What you learned from this is that in geometry, you need to have a holistic knowledge. So you have to understand cube, you have to understand triangle, you have to understand centroid and the height of the triangle and the combination of both of them. And once that holistic knowledge is being gained, actually geometry can become very, very easy. Let us move on to the third question, which is also a CAT 2004 question, but this one is based on circles and it really looks scary. Let's have a look. A circle with radius 2 is placed against a right angle. Another smaller circle is also placed as shown in the adjoining figure. what is the radius of the smaller circle. Now, by the look of it, it really looks difficult because the smaller circle is at the very corner, and how do I find the radius of the smaller circle? Let's say, to start with, the radius of the smaller circle be small r. Now, also let's name the points. So O1 and O2 are the centers of the circle. A, L, as shown in the figure, are the points on which the perpendiculars are dropped from the center of the circle. So they are also the radiuses, but A and L are also perpendicular on the baseline, and C is the point of intersection of the two circles. So by the look at the figure, we can clearly see that O1A and AB both are equivalent to the radius of the bigger circle, which is 2, and therefore by the Pythagoras theorem, O1B will be equals to 2 root 2. Also, we know that O1C and CB will be equals to O1B, but we can break CB into CO2 and O2B. Why am I doing this? Because I know that CO2 is small r, and O2B I can clearly see can be found out as small r into root 2. And if I add the equation, what do I have? I have 2 plus r root 2 is 2 times of root 2, and therefore on solving I get r is equals to 6 minus 4 root 2. So what did we learn is that just by drawing a big clean figure and a simple use of Pythagoras theorem, a scary looking question like this can also be quickly solved. Let's move on to the fourth question, and this is a CAT 2005 question. Once again, CAT 2005 had 1 markers and 2 markers, and I picked up this question because this is a 2 marker and students feel that it is difficult. Is it really? Let's check. So here is the question. Consider the triangle ABC shown in the figure where BC is 12, DB is 9, CD is 6, and angle BCD is equals to angle BAC. What are we supposed to find? We are supposed to find that what is the ratio of perimeter of triangle ADC to that of triangle BDC, and the options are given to you. Now, what do you think can be done in the question like this? I think a very clear cut hint is being given to you by giving that angle BCD is equals to angle BAC. If I look at these two triangles ABC and CBD, one angle is already given equal in the question, and we also know that angle B is common in both the triangles, which means if I can prove that two angles are equal in both the triangles, the third angle will automatically be equal, and therefore the two triangles ABC and CBD will be similar. Now, the moment I have proved them similar, I know that AB is to BC and BC is to BD and AC is to CD will be all equal. What do I all know? I know that BC is 12, I know BD is 9, and I know CD is 6. With this, I can clearly find out that AB is 16 and AC is 8. The moment I find this, I can find the perimeter of triangle ADC, because AD can be found out by AB minus BD, which is 16 minus 9, and that is 7. Similarly, DC is given to me as 6 and AC I have found out as 8. So if I add up 7 plus 6 plus 8, I get a 21, which is the perimeter of triangle ADC. Triangle BDC already has a perimeter given in the form of 12 plus 6 plus 9, and that is 27. What I needed to find out is the ratio. So 21 is to 27 is 7 is to 9, which is option 1. So a 2 marker question of CAT 2005, which is supposed to be difficult, can only be understood very easily if you understand similar triangles and apply it in the question. So here's the question. P, Q, S and R are points on the circumference of a circle of radius r, such that PQR is an equilateral triangle and PS is the diameter of the circle. What is the perimeter of the quadrilateral PQRS? Now, the figure was not given in this question, and therefore we are supposed to draw our own figure. So you first need to draw a circle, and in that circle, first thing that you should do is draw an equilateral triangle PQR. The moment you draw an equilateral triangle, you understand that it should be symmetric, and therefore if all the angles of the equilateral triangle are 60, 60, 60, now you also have to draw a point S which lies on the diameter PS. So from P to S, if you join a line, this line will be the diameter and this point S will be the part of the quadrilateral whose perimeter I am supposed to find. Now, first things first, let's first find the length PQ and QR and PR, which are the sides of equilateral triangle. By a clear look at it, I know that if the radius is small r of the circumcircle of the equilateral triangle, we know that capital R, the circumradius, is equals to 2/3 times the height, or on the contrary, height is 3/2 times of the radius. But height is √3/2 times the side of the equilateral triangle, and therefore side of the equilateral triangle is equals to √3 times r, which clearly gives me the two sides of the quadrilateral PQ and PR, and their lengths, as we calculated, is √3 times the radius. Now moving on, what do we have? We have to find QS and RS. How can we find that? If we join P and S and join Q and R, and let's say they intersect at the point, let's say L, what do we have is, because of symmetricity, angle PQR is 60 degree, PS and QR are intersecting at L. We know that angle PQR is 60 degree because it's a equilateral triangle, and therefore all the angles are 60 degrees. We also know that angle QPL will be 30 degree because this line PS is symmetric on both the sides, so it should divide the equilateral triangle into equal halves, and therefore the angle also should be equal, and therefore QPL is 30 degrees, because of which I get angle QLP as 90 degrees, and that gives me the master stroke of 60, 30 and 90 triangle. We know that in a 30, 60, 90 triangle, the sides are in the ratio of 1:√3:2, and as PQ is √3r, therefore QL will become √3r/2, and because QL is equals to √3r/2, now I can come in triangle QLS, which in fact is also a 30, 60, 90 triangle, and giving me the length of QS as r. Because QS is r, similarly RS will be r, and here I get all the four sides of the quadrilateral, because PQ we already identified as √3 times r, PR is also √3 times r, QS is r and RS is r. If I add all four of them, I get the perimeter, which is my answer option 1, which is 2r into bracket 1 plus √3. So yes, a fairly difficult question, but with a simple understanding of equilateral triangle and 30, 60, 90 triangle, this question can be easily cracked to find the area of quadrilateral. What you could visualize is a quadrilateral, a triangle, and triangle also of two types, 30, 60, 90, and equilateral in the circle. So a combination of 3 or 4 good topics makes this question, and that is what makes CATS a beautiful exam, but not very difficult, because a holistic knowledge on geometry can make the whole chapter very easy. Let's move on to the next question and see. This one is a CAT 2006 question, once again based on a circle. Let's see the question. So this is the question. A semicircle is drawn with AB as its diameter. From C, a point on AB, a line perpendicular to AB is drawn meeting the circumference of the semicircle at D. Given that AC is 2 cm and CD is 6 cm, the area of semicircle will be how much? So in this question, again the figure is not given, we will have to draw our own figure. Make sure, my friends, that you draw a little bigger and clear figure, because that is the key to solving geometry very quickly. So let's look at the figure. We have a semicircle, AB is the diameter, let's say O is the center of this circle or a semicircle. Now OD, let's say assuming it is small r, I have CD given to me as 6, AC is given to me as 2. Now I know that OC will be equals to r minus 2 because OA is the radius. So I can simply solve this question by applying a basic Pythagoras theorem. saying OD square is equals to CD square plus OC square. Thus R square is equals to 6 square plus R minus 2 ka square, and on solving R I get R as 10. If R is 10, the area of circle will be pi times 10 square over 2. Why over 2 is because I am finding the area of semicircle, and that comes out to be 50 pi. In fact, you don't even need to solve this whole thing, because the moment you see a R and R minus 2 along with a 6, and if you remember a Pythagorean triplet 6, 8, 10, you can easily obtain the answer as 10, and the moment you get an answer as 10 for the radius, you get the semicircle area as 50 pi. I am sure you all will believe with me when I say that this one was a sitter given by CAT in 2006. Let's move on to see another CAT question that came in 2006. So here comes the question. An equilateral triangle BPC is drawn inside a square ABCD. What is the value of angle APD in degrees? So once again, the key to solve a good geometry question is drawing a big and a clear figure. Let's draw the figure. ABCD is a square and BPC in that is an equilateral triangle as shown to you. Now, the moment I say BPC is an equilateral triangle, all the angles will be 60 degrees. And because the angle PBC is 60 degrees, angle ABP will be 30 degrees because it's a square. So square, all the angles are 90 degrees. So if one angle is 60, another part of it, which is ABP, has to be 30 degrees. Now in triangle ABP, we know that AB and BP are both same. Now how is that? Because it's a square, all sides are same, and the equilateral triangle has one side as the side of the square, and therefore sides of AB and BP are same and both are the side of the square, and therefore angle BAP and BPA both will be equals to 75 degrees because they are the remaining parts of the equilateral triangle whose one angle is 30 degrees, and we know that sum of all angles is 180. Now the moment BAP is 75 degrees, we can similarly prove angle DPC will also be 75 degrees, and at the point P, if I draw a complete circle, we know that in a circle all the angles will be summing up to a 360 degrees, and therefore 60 degrees of BPC plus 75 degrees of CPD plus DPA, which I need to find, and plus APB, which is also 75 degrees, will sum up to 360 degrees, and therefore APD I can solve and find out will come out to be 150 degrees. So another not so very difficult question that was asked in CAT. You should be understanding that in geometry, most of the questions that can come in a competitive exams are based on triangles and circles. So if they are being made strong by the students, the whole geometry can be done very quickly. Let's move on to understand one last question that came in CAT, but this one was based on circles. So the question is, two circles, both of radius 1 centimeter, intersect such that circumference of each one passes through the center of the circle of the other. What is the area in square centimeter of the intersecting region? And the options were given like this. Now, once again, looking at the question, the figure is not given, so I have to draw a clear big two circles such that they should be intersecting each other in such a way that the circumference of one passes through the center of the other circle, which clearly indicates that both the circle, let's say as shown in the figure drawn by me, with the centers O1 and O2 will be intersecting each other, and the length of O1 O2 because of the same reason will be equals to 1. I need to find out the region A, O1, B and O2. Now to find the area of this region, what can we do? Let's first look at the area which is above the line O1, O2, and what we'll do is we will double it down. How to find the area of the shaded region is the most important part of the question. We can simply subtract the area of triangle O1, O2A from the sector O1, O2A once again, but the sector is a bigger part which is having an angle subtended at the center of 60 degrees. So the area of sector is 1 by 6 times pi times 1, because 1 is the radius, and from that we are subtracting root 3 by 4 times 1 again, because the 1 is again the length of the equilateral triangle. So I get the area of shaded region How many such shaded regions are there? Actually, there are 4 such shaded regions in this complete answer. So I have to find 4 times of pi by 6 minus root 3 by 4 plus 2 times the equilateral triangles. Which are the equilateral triangles? O1, O2A and O1, O2B. If I add them all, I get my answer, which is 2 pi by 3 minus root 3 by 2, which is the area of the intersecting region. So the learnings that you can take away from this video are actually 3. First, that in CAT, questions of geometry are not just based on triangles or not just on circles or polygons or quadrilaterals or coordinate geometry, but they are basically a combination of 3 or 4 topics in one particular question. So a student must have prepared on all the topics, or at least have gone through and solved questions of all different topics separately. Secondly, if a proper theory notebook is being prepared, a separate theory notebook, my friends, is very important for CAT preparation, because it is completely dependent upon whether you know a concept, whether you know a theorem or not as far as geometry is concerned. And revising those things continuously till the CAT day is of high importance. Third, and probably the most important thing that a student should remember, is that geometry is not that difficult, and a continuous practice and remembering the theorems can make you a master of geometry also. Thank you. Happy cracking.